Hi guys, this is Srinivasa once again for you. Today we are going to discuss about bigger method. In previous videos we discussed about simplex method. Now this is the time for discuss bigger method. So only thing is when we have to use this bigger method. So that is if you check the constraints. So obviously we will have some sort of difficulty obviously. So in the first equation the maximum availability is 30. In the second one we have 24, in the third one the minimum availability is 3, from 3 to undefined. So for this case we are going to use bigger method. The solution for this as follows all of you. So as usual, first we have to change the inequalities into equalities by introducing slack variable for the first constraint and surplus variables for the third constraint. So that is all of you, that is 2x1 plus 3x2. So this is in the form of less than or equal to type. So way back in simplex method we use slack variable s1. So obviously s1 that equal to 30 and one more 3x1 plus 2x2 plus less than or equal to 24 means, so again we have to introduce our slack variable s2 that equal to 24. And finally x1 plus x2, this is in the form of greater than or equal to 10. So that is away from, so we have to introduce a surplus variable. So and surplus variable, surplus means subtracting one and addition some sort of artificial variable a1 that equal to 3. If you have one more grammar code type, then we have to use minus s3 plus 80. Clear? So s1, s2, s3 are the slack variables and a1 is the artificial variable. So now after this we have a step, that is the standard form of matrix is ax equal to b. That's write down all the variables. x1, x2 we have s1, s2, we have s3 and we have a1. So simply we have to write down all the matrices. So that is for x1 we have 2, 3. In the first equation we have s1, that the cost will be 1 and we don't have any sort of variables in the first equation. In the second one we have 3, 2, 0, 1, 0, 0. And in the third equation, that is 1, 1, we don't have s1, we don't have s2 and we have minus s1 and the cost of the artificial variable is 1. This is all about. Make sure that this is all about the identity matrix. 1, 0, 0, 0, 1, 0 and 0, 0, 1. We have our x means, so all the variables. So all the variables are x1, x2, s1, s2, s3 and artificial variable a1 that equal to, we have a b, what is b? 30, 24 and single number 3. These are. After this, the modified objective function. So the modified objective function is all of you maximum of z equal to the given, that is 6x1 plus 4x2 plus we introduce a slack variable s1 in the first constraint. So the cost of this slack variable is 0 into s1. In the second equation we introduce slack variable s2, that is 0 into s2, and in the third one 0 into s3, and we introduce an artificial variable. The cost of the artificial variable a1 is minus m. So we are giving the importance to the artificial variable that the cost is minus m. So that is the reason why this method is called as big M method. So most of the candidates are saying that it's big M method. It's not a big M method, it's big minus M method. So now we are applying some sort of a penalty. This method is also called as penalty method. Now we have to consider this. From this data we have to draw some sort of iteration tables. Now we will move on to the first iteration table. The first iteration table. The first iteration table, all of you, we have our CB, YB, XB and variables x1, x2, we have s1, s2, s3 and we have a1. So that is, so we have a CJ. What is CJ? The modified objective function. So the cost of x1 is 6, 4, again 0, 0, 0 and the introduced artificial variable cost will be minus m. Now in the first equation, just if you observe the constraints all of you, in the first equation we introduce slack variable s1. In the second equation we introduced s2. Whereas in the third equation we introduce some sort of a slack and surplus variable, that we have to give the artificial variable importance, so that is a1. The cost cost of this A1 is obviously minus m. Here we have a minus m. The introduced slack curve S1 S2, that is S1 S2, the cost will be 0 and 0 as usual. That's it. X equal to B, that is what is B? That is 30, 24, 3. 30, 24, 3. And simply we have to write out the entire matrix, that is 2, 3, 1, 0, 3, 2, 0, 1, 0, 0, and finally 1, 1, 0, 0, minus 7 and 1. And after this, we have a maximization formula. What is the formula for maximum of Z? So the maximum of Z equal to summation CB into XB. That equal to 0, 0, minus m into 3, that is minus 3m. So all of you, I am going to multiply CB with XB. CB values with XB values. 0 into 30, 0, 0, minus m into 3, then that is minus 3m. After this, we have a ZZ formula. The formula for ZZ is summation CB into XG. 0. If I put Z equal to 1, that is X1. If I put Z equal to 2, that is X2. And so on. 0 into 2, that is CB into, if I put Z equal to 1, that is X1. CB into X1. 0 into 2, 0. 0 into 3, 0. Minus m into 1, that is minus m. 0, 0, again minus m. So obviously 0, 0, minus into minus plus m, and again minus m into 1, that is minus. Why? Because these two are 0, so obviously the values will be 0, and the rest of the thing that is minus m into some sort of value we have to multiply. Now we have a net equation condition Zj minus Cj greater than or equal to 0. That is minus m minus 6, so that is minus m minus 6, minus m minus 4, 0 minus 0, 0, m minus 0 again 0, 0, m minus 0 again m, minus m, minus 2 minus plus m. So the net equation condition is Zj minus Cj greater than or equal to 0. In this case, the net equation condition is not satisfied, so we have to consider minus of maximum element. So if you take minus s common m plus 6, if you take minus s common m plus 4, if you put m equal to 100, this is minus 106, this is minus 104, so that is minus of maximum is obviously this one, that is minus m minus 6. If we put m equal to 100, obviously we will get the values. After this we have a minimum ratio rule, that is xb by xj. So this arrow indicates x1, so that is x1 simply. If for example we have m minus 8 here, then this arrow indicates x2, so we have to put x2 and so on. So that is xb by x1, 30 by 2, that is 15, 24 by 3, 8, 3 by 1, that is 3. Yeah, so here we have minus of maximum, we have to consider plus of minimum from these two. So obviously the plus of minimum is 3. If you combine these two, one is the key element. Because of this key element only, we are not going to satisfy this condition. Now we have to make this key element as unity by dividing it. So luckily, we have the key element as unity. So it's not at all required to divide again. After this, we have in the second iteration table, x1 is incoming vector, a1 is outgoing vector. When we are going to, for this artificial variable is going means, we have to delete this entire column, but not in case of a simplex method. Now, the second iteration table, after that, we have to make these two elements as 0. Now, the second iteration table as follows. Now, the second iteration table. That is again we have CB, YB, XB, X1, X2, we have S1, S2, S3. Why? Because all of you once again, X1 is incoming here and A1 is outgoing. So A1 is outgoing means obviously we have to delete this A1 column entirely. Now the cost of this x1 is 6 and there is no changes for s1 and s2. So obviously s1 will be here, s2 will be here, the cost will be 0 and 0. Now we have to make this key element as unity by dividing itself. Obviously the key element is 1. It's not at all necessary to make again 1. So that is simply I'm writing the same data 3, 1, again 1, 0, 0, minus 1. For example, if you have a Now we have to make all these two elements as 0 by using some sort of row operation or column operation. Now I am taking some sort of a rough here, all of you. That is to make this 2 as 0. Now we have to make this 2 as 0. 2 as 0. So simply we have to write this 30, 2, 3, 1, double 0. With the help of the key row. That is 3, 1, 1, 0, 0, minus 1. So we have to get 0 here. So we have 2, here we have 1. So without loss of generality, I am multiplying with 2 here. 2 into 3, 6. 2 ones are 2, again 2 under 2, 0, 0, minus 2. Now I am subtracting these two to get 0 here. That is 30 minus 6 is 24. 2 minus 2 that is 0. 3 minus 2 that is 1. 1 minus 0, 1. 0 minus 0, 0. 0 minus 2 minus plus 2. I am writing this entire row in the first row. That is 24 here. 0, 1, 1. We have 0, 2. Clear? Now we have to make this 3 as 0. So again the same tempo or the same step all of it. So we have to make this 3 as 0. So we have to write this entire row once again. So that is all of you. 24 I am writing here. 24, 3, 2, 0, 1, 0. Again I am taking the key row. That is 3, 1, 1, 0, 0, minus 1. In the previous step of it, we got 2 here. Simply we are going to multiply through, but not in this case. We have 3, so that's why I am going to multiply with 3. 3 3s are 9, 3 1s are 3, again 3 1s are 3, 3 zeros are 0, 0, 0, that is 3. Now we have to subtract minus. 24 minus 9 is 15. 3 minus 3 is 0, 2 minus 3 is minus 1, 0 minus 0, 1, 0 minus 2 minus plus 3. Now we have to write this entire row, that is again 15. 0, minus 1, 0, 1, 3. So obviously we made this key element as 1 and all the elements as 0. So obviously we are going to. Now again we are going to check all the conditions including the net diversion condition. What is the form of a maximum z? So maximum z is summation CB into XB. CB into XB. 0 into 424, 0, 0, 6 3s are 18. And we have a ZZ. The formula for ZZ is summation CB into X. 0, 0, 6 1s are 6. 0, 0, again 6 1s are 6. 0, and again 0, and again minus 6. Okay, and again we have a Cj here. The value for Cj is 6, 4, 0, 0, 0. After this we have a net diversion condition Zj minus Cj greater than or equal to 0. 6 minus 6, 0. Zj minus Cj, 6 minus, again 6 minus 4 that is 2. 0 minus 0, 0. 0 minus again 0. Minus 6 minus 0 that is again minus 6. A bit. So all of you here also we are not going to satisfy the condition that is Zj minus Cj greater than or equal to 0. So in this case we have to consider minus of maximum. Again we have only one minus of maximum. In the previous problem we got 2 minus, here we got 1 minus. So we make sure that in the third table we are going to get all the values are positive. Again the formula as usual, the minimum ratio rule, xb by, so we have, so this arrow will indicate S3, that is 24 by 2, 12, 15 by 3, and 3 by minus means negative. So in this case we have to get, here we have to observe minus of maximum, here we have to observe plus of minimum. So from these three we have plus as minimum is fine. If you combine these two arrows, the key element is 3 key element. So because of this key element only we are not going to find this condition positive all of it. So now we have to make this 3 as 1, and as usual S3 is incoming vector, S2 is outgoing vector, the cost of S3 is 0, and make all the elements in the key column has to be 0. So now we will move on to the last iteration table, that is the third iteration table. That is all of you, third iteration table. Again we have CB, YB, xv, x1, x2, s1, s2, s3. That is again serial. 6, 4, 0, 0, 0. So obviously, here we have this S3 now. So S3 will be here. So S3 will be the incoming vector, S2 will be the outgoing vector, and the cost of S3 is 0. So make it a point, for artificial variable is outgoing means you have to remove that artificial variable entirely from the iteration table, but not for the slack variables. Okay, make it a point. So no changes for S1 and again x1. The cost of x1 is 6 here, and for S1 that is 0. Now we have to make this key element as unity. That is where we are going to divide this entire row by 3. 15 by 3, 5, 0, minus 1 by 3, 0, 1 by 3, and again 1. Now we have to make this 2 as 0. So as usual. So now I am going to take that entire row, that is in rough 24, 0, 1, 1, 0, 2 with the help of the key row. 5, 0, minus 1 by 3, 0, 1 by 3 and 1. Now we have to get 0 here. So we have a 2, we have 1. So without loss of generality, I am multiplying with 2. 5 2s are 10, 0, minus 2 by 3, 0, again 2 by 3, 2. I am going to subtract these 2. 24 minus 10, that is 14. 0 minus 0, 0. 1 minus 2 minus plus 2 by 3, that is 5 by 3. 1 minus 0, 1. 0 minus 2 by 3, minus 2 by 3. And 2 minus 2, that is 0. I am going to write this entire row in the first row, that is 14, 0, 5 by 3, 1, minus 2 by 3, 0. So we make the key element as unity and all the values as 0. So obviously 2 becomes 0. Now we will move on to make this minus 1 as 0. Now we have to consider this entire row in the rough sheet. All of you. So I am going to write that entire row. So we have to make that minus 1 as 0. That is I am making 3, 1, 1, 0, 0, minus 1 with the help of the key row. 5, 0, minus 1 by 3, 0, 1 by 3, 1. Luckily, so we have to get 0 here. Luckily, we have minus and plus 1. Simply, if you are going to add these two, obviously we can get 0. That is 5 plus 3, 8. 1 plus 0, 1. 1 plus 0 minus 1 by 3. That is 2 by 3. 0 minus 0, 0. 0 plus 1 by 3, 1 by 3. Obviously, minus 1 plus 1 is obviously 0. And I am going to write this entire row in the third row. That is 8, 1, 2 by 3, 0, 1 by 3, 0. Clear? So after this, we are going to find all the three conditions. So that is maximum of z. The formula for maximum of z equal to all of you summation cb into xb. 0, 0, 6 8s are 48. And the formula for zj, that is summation cb into xj. 0, 0, 6. 0, 0, 6 2's 12 by 3, 3 4's are 12. 0, 0, again 0. 0, 0, 6 by 3, that is 2. Again 0, 0, and again 6 into 0, again 0. And we have a net aversion condition, zj minus cj greater than equal to 0. 6 minus 6, that is 0. 4 minus 4, that is once again 0. 0 minus 0, 0. 2 minus 2, again 0, that is again 2. Hence, all the net aversion conditions are satisfied. That is, all the values are positive. Hence, the solution is in optimum. That is, the maximum of z is all of you. That is 48. x1 is 8. We don't have x2. That is 0. Hence, we are going to write the conclusion here. That is, max z equal to 48. x1 is 8. x2 we don't have 0. So what it means, a company could make a profit of 48 rupees if you are going to fix the cost of a first product is 8 and x2 is nil. Now we are going to check it. The given object function is max z equal to 6x1 plus 4x2. So we got x1 as 8, and x2 as 0. Why it is 0 in the sense? In the iteration table we don't have x2, so obviously we have to consider x2 as 0. That is 6 8 is 48 plus 0, obviously 48. That's it. Here we have 48. Hence the solution is optimum. Have a fantastic day, guys. Thanks a lot for watching this. Thank you.